Everyone, welcome back to part 2 of the chapter Mensuration for class 8. After revising the area of different shapes in the last section, we're now going to move on with the exercises covered in this chapter. Let's start off with exercise 11.1, question 1. A square and a rectangular field with measurements as given in the figure have the same perimeter. Which field has a larger area? Now, we can observe that both the figures have the same perimeter. Now for a perimeter, square's formula is 4s, wherein s is the side, and the rectangle is 2 into L plus b. Now let's see if we can calculate the perimeter. For the square, we have s, so we can calculate, that's confirmed. But for the rectangle, we have 2 into L plus b. The length is given, but not the breadth. Since they are the same perimeter, we'll try calculating the perimeter of the square first and then the rectangle. So now that the perimeter of the square is 4s, s is equal to 60, so 4 into 60, which gives us 240 meters. Which means that the perimeter of the rectangle is also 240 meters. So let's plug in the formula and test this out. 2 into L plus b is equal to 240. Now let's transpose this 2 to the other side. So L plus b is equal to 240 by 2, which is equal to 120. Now that L is given, we can transpose it. 80 plus b is equal to 120. And if we bring the 80 over to this side, it means b is equal to 120 minus 80, giving us 40. That means the breadth of the rectangle is going to be 40 meters. Now you might be wondering, why did we calculate the breadth when they had asked us for the area? Well, again, for a square, the area formula is s square, but for a rectangle, it's lb. And again here, we need the breadth. So we calculated the breadth to the previous perimeter formula. Now let's calculate the areas of both of them. Area of the square is going to be s square. By transposing s, we get 60 square and gives us 3600 meters square. Now let's calculate the area of the rectangle. It's LB, which is equal to 80 into 40, and that gives us 3200 meters square. Now by judging at it, we can observe 3600 is clearly greater than 3200. So area of the square is greater. I hope you guys understood the question. Let's now move on to the next question. Ms. Kaushik is a square plot with the measurement as shown in the figure. She wants to construct a house in the middle of the plot. A garden is developed around the house. Find the total cost of developing a garden around the house at the rate of 55 rupees per meter square. Alright, now we're given a question to find out the total cost of developing a garden. Now if we observe something over here, we have measurements of the house and the total area, however not the area or the perimeter measurements of the garden. So how do we figure out the area? Well, if we infer the figure, we can see that the garden is the remaining space between the total area and the house. So if we just put it around like this, the area of the garden is equal to total area minus the area of the house, because the garden is the remaining area. So that works, right? In that case, let's calculate the total area and the area of the house. Now, total area, as you can see, it's a square, 25 into 25. And since it's s square, it's 25 square or 625 meters square. And now the area of the house. It's a rectangle with length as 20 and breadth as 15. So using LB, it's going to be 20 into 15. So that gives us 300 meters square. So what's the remaining area of the garden? Since it's total area minus area of the house, that's 625 minus 300, which gives us 325 meters square. Now we've got the area of the garden. Now we have to find the total cost of developing a garden around the house at the rate of 55 rupees per meter square. So in order to find the total cost, just a simple formula. Cost into the area of the garden. Now what's the cost? 55 rupees meter square. And what's the area of the garden? 325 rupees per meter square. If we multiply this, we get 17,875 rupees as our final answer. So the total cost of developing a garden around the house is going to be rupees 17,875. I hope you guys got this question as well. Let's now move on to the next one. Question 3. The shape of a garden is rectangular in the middle and semicircle at the ends as shown in the diagram. Find the area and perimeter of this garden. Length of a rectangle is 20 minus 3.5 plus 3.5 meters. Okay, let's decode this shortly. Let's start off with the perimeter first and then the area. Now, as for the perimeter, we can see that the length of the rectangle is given. It's 20 minus 3.5 plus 3.5. 3.5 plus 3.5 is nothing but 7. So 20 minus 7 is equal to 13 meters. Now we can observe that the length, that is this length, is going to be 13 meters. And since it's on the other side also, this side is also going to be 13 meters. Now to find out the entire perimeter, we have to find out the lengths of this circumference as well. We have two semicircles as shown. A very simple rule. Two semicircles is nothing but an entire circle. That means if we calculate the circumference of an entire circle with this diameter or so, it just means we can figure out the perimeter of both of the semicircles over having to calculate it manually. So in that case, let's plug in the circumference formula and test this out. Circumference formula for a circle is 2 pi r. We're taking this as a whole, not half, because both the ends combined is going to be a circle. So 2 pi r. And so if we just rephrase this, just pi into 2r. And what is 2r? A diameter. So pi d is the formula. The diameter over here, this length is 7 as represented in the figure. So if we simplify this, pi as in 22 by 7 into d, 7 by 1. That gives us, if we cut off the 7s, we have 22 as the circumference of both the circles. So now we've got that as well. Now the perimeter, if we just add these two, circumference, which is 22 meters, and these two lengths, which was 13 and 13. 22 plus 26, 13 plus 13 is equal to 48 meters. Therefore, we've got the perimeter of the entire figure as 48 meters. Hope you guys understood that. Now for the area. Now area, again, we have to divide this into two halves and the rectangle in the middle. Let's start off with the rectangle first. We've got it that the length of the rectangle is going to be 13 meters. And again, the breadth here itself is shown, so 7 meters. And this is the formula is LB. We're taking 13 into 7 as 91 meters square. Hope you guys got that. Now we're going to figure out the area of the circles. Now what's the area of the circle formula? Pi r square. So now using this, we have 22 by 7 and the radius is 3.5 or 7 by 2 because this is the diameter. This is the diameter. Again, we're going to use pi r square for an entire circle because both of them combined is an entire circle. So we're going to use it that way. And if we calculate it, we're going to get 7 by 2 into 7 by 2, which is just 7 by 2 square or r square. Now we'll just cut this off. 11. And then simplified it, we get 77 by 2, or in decimal forms, we get 38.5. So now we've got the area of the semicircle as well. These two areas are done, 38.5. This area is also done. So now for the total area, we just added 91 m square for the rectangle and 38.5 m square for the circles. So that in all gives us 129.5 meters square as the total area. I hope you guys got that question. Let's now move on to the next one. A flooring tile has the shape of a parallelogram whose base is 24 centimeters and the corresponding height is 10 centimeters. How many such tiles are required to cover a floor of area 1080 meters square? Okay, let's decode this one by one. It has the shape of a parallelogram whose base is 24 and the corresponding height is 10 centimeters. How many such tiles are required? Now for this, we'll have to find out the area of one of it and divide it by the total area so we get the amount of tiles. So what's the area formula of a parallelogram? It's BH, base into height. So this 24 into 10 is equal to 240 meters square. Sorry, my bad, centimeters square. This is very important Note down the units while you're doing any equation because the units are centimeters. Okay, now how many such tiles are required to cover a floor of area? So one tile is equal to 240 centimeters square. And the area of the floor is 1080 meters square. Now meter square and centimeter square is not the same thing. So make sure to look at your units while doing so. 1 meter square is equal to 10,000 cm square. So now to convert this into cm square to be a feasible unit for this, we'll just add and multiply, which gives us 10.8 million centimeter square, or 1080 and 40 followed. So now that's gonna be the area of the floor, and that's gonna be the area of the tile. So now what we do, we just divide and simplify this. Cut off the zeros, and if you simplify it, all in all, you get 45,000 tiles as your final answer. I hope you guys got that. Let's move on to the final question of exercise 11.1. An ant is moving around a few food pieces of different shapes scattered on the floor. For which piece would the ant have to take a longer route? Remember, circumference of a circle can be obtained by using the expression C is equal to 2 pi r, where r is the radius of the circle and C is the circumference. Okay, let's name this as shape A, shape B, and shape C. Let's start off with the circumference of shape A first. Now, we know the circumference of a circle is 2 pi r. And here, we not only have to calculate the circumference of the semicircle, but also another length. So, let's denote this as a formula. Circumference of A is going to be 2 pi r by 2. Because the entire circumference by 2. This is not a full circle, it's a semicircle. Plus the diameter, here d. Now, if we just simplify this and cut off the 2's, we just get the circumference of A is equal to pi r plus d, or 2r. So now let's simplify those first. 22 by 7 is going to be, we're going to calculate pi r now for A, okay? So 22 by 7 into the radius, which is 1.4. 1.4 is nothing but 14 by 10. So if we cut this, we get 2 here, 1. Cut this off, 11 and 2, which is 22 by 2. 5, sorry. 22 by 5, which then gives us the answer of 4.4. I hope you guys got that. Now we've calculated pi r. Another thing we have to calculate is d, and here that's just 2.8. So straightforward, 4.4 plus 2.8 is equal to 7.2 centimeters. That's going to be the circumference of figure A. So now let's mark that here, 7.2 circumference. We'll calculate the circumference for the next one as well. Now here for circumference B, we can see that it's a type of a rectangle, except this side has been cut off and replaced with a semicircle with no diameter. So if we see some measurements here, we have to add this measurement, this, and this circumference measurement. So now we'll just take 2 pi r by 2 as a half, which is just pi r, considering the semicircle over here. And then we add 1.5, 1.5 on both sides. So 2 into 1.5 and then 2.8. Okay, so let's simplify this step by step. Again, it's going to be pi r for this one. And since it pretty much has the same diameter here, we're going to put that as 4.4 because this 2.8 and this 2.8 is the same measurement. So we just put that out. Now for the entirety, we have 1.5 into 2, both sides circumference. So 1.5 into 2 is 3 plus this length over here plus 2.8. So if we simplify it, 7.4 plus 2.8, we now get 10.2 as our final answer. So now circumference of figure B is going to be 10.2, The first one was 7.2. Now finally for figure C. Again, there is not much we have to do here. The lengths are already given. And circumference of C, we already have this length. So let's just take that as pi r now. No need of simplification. And then 2 lengths we can just add. Plus 2 into 2, aka 4. Okay, so that's done. Now pi r again over here, it's 2.8 for all of them. So we'll just take that as 4.4 plus 4, which means that gives us 8.4 centimeters. Now that we have got all the lengths, we found out that the circumference of figure A is 7.2, figure B is 10.2, and figure C is 8.4. Now we have to see which foot piece will take a longer round. Now clearly 10.2 is greater than 7.2 and greater than 8.4. Therefore, the ant has to take a longer round for foot piece B. I hope you guys got that. Now we've officially completed exercise 11.1, all of the questions. Let's now move on to exercise 11.2. Okay. The shape of a top surface of a table is a trapezium. Find the area if its parallel sides are 1 meter, 1 meter and 1.2 meters, and the perpendicular distance between them is 0.8 meters. Now this is going to be very simple. We already know the formula, which is 1 by 2h into d1 plus d2. Now using the figure here, we can find 0.8 is going to be the height, 1 meter d1 and 1.2 meters d2. So if we simplify it, 1 by 2 in 0.8 into d1, 1 plus 1.2. So 0.8 halved is 0.4 and 1.2 plus 1 is going to be 2.2. So now 2.2 into 0.4 is nothing but 0.88 meter square. I hope you guys got this question as well. And now we'll move on to the next one. The area of a trapezium is 34 centimeters square. The length of one of the parallel sides is 10 centimeter and the height is 4 centimeter. Find the length of the other parallel side of the trapezium. Now it's mostly a method of transposition over here. So let's take this as an example figure. This area is going to be 34 centimeters square. Length of one of the parallel sides, let's take this one, is 10. Height is 4. Find the length of the other parallel side of the trapezium. Now this is very easy. We know that the formula of calculating the area of the trapezium is 1 by 2 h into d1 plus d2. So if we simplify it further, 1 by 2 into 4 d1, or let's take 10 as d2, so plus 10 is equal to 34. So if we half 4 over here, it gives us 2 into 10 plus d1. We don't know what d1 is, which is equal to 34. So we transpose this 2 over here. So 10 plus d1 is equal to 34 by 2 or 17. Now again 10 plus d1 is equal to 17, and therefore d1 is equal to 17 minus 10 aka 7. Therefore we got the answer that the other parallel side of the trapezium is going to be 7 centimeters. Hope you guys got that question. Let's now move on to the next one. The length of the fence of a trapezium shaped field is 120 meters. If BC is equal to 48, CD is equal to 17 and AD is equal to 40, find the area of this field. Side AB is perpendicular to the parallel sides AD and BC. Okay, let's decode this figure. We have a figure as shown. A, B, C and D. Now BC is going to be 48, CD is 17 and AD is 40. Find the area of this field. Side AB is perpendicular to the parallel sides AD and BC. Now to find the area of a trapezium, we need parallel side 1, parallel side 2 and the height. However, here the height is not given and we have the lengths of all three sides. So what do? We'll just subtract it from the total perimeter. Now total perimeter is 120 minus, add all of these lengths, 40 plus 17 plus 48, which gives us 120 minus 105, giving us 15 meters as the height of this trapezoid. Okay, now that we've got the height as well, let's use the formula and find out the area of this field. 1 by 2 h into d1 plus d2, where the height was given as 15 and d1 plus d2 is 40 plus 48. So if we shorten up this formula, we have 15 by 2 into 88, and that gives us with 1320 by 2, and this all in all it gives 660 meters square as our final area. Again, for all of you for viewing this video, please make sure to like and subscribe for more lessons and explanations as we continue on with more parts of this lesson and moving around various topics of surface area, volume and continuing the other exercises. Thank you so much and have a great day ahead.